Okay, so the idea now is to talk about generative adversarial networks, abbreviation of GAN, GAN. The idea is that we have the discriminator and the generator. The discriminator purpose is to know if the input that we are streaming to him is real or fake. We are training the discriminator of our data. So the discriminator, like neural network, learns our data. We are totally normal, inserting data from our dataset, going throughout the discriminator and teaching him our data. Namely, we are inserting data saying it's real, and we are taking some fake data and saying here discriminator, those are the real images, those are the fake images, learn using neural network and backpropagation and all of this to discriminate, namely give me an answer if the image that I insert now is real or fake. We're doing it in supervised way, so I give him a real image, tell him that it's real, namely labeling it's real like 1, and get the answer. If the answer is false, so the loss function will be higher. We are using cross entropy for yes or no. So this is our loss function. And I am giving him fake images, labeling it's fake as a fake, let's say 0, and teaching the discriminator, giving it to the network, and getting the label if it's real or fake, and if he's wrong, so we are uh, updating like neural network that learns how to differentiate a bunch of sample from others. A bunch is called the real images and a bunch is called fake images, and I teach him from the generator I make fakes, from the real world I get the real images. So the discriminator learns and learns and learns using backpropagation, gradient descent, and all of this to train the network to learn real and fake images, such that when I insert him an image, he knows how to tell me if it's real or fake. Then I'm going to the generator. I want to train the generator to know to create images that are as similar as possible to real images. The idea of the generative adversarial network is, for example, to create generators that knows to generate data that is very similar to the real world data, like images. Like images. I want him to generate images that are as real as possible to my training data, to our training set. So after I train the discriminator, to differentiate between real and fake, fake comes from the generator, real comes from the dataset from the real world. I go to the generator and then I tell him, make images and process them throughout the discriminator. Generator, you want that the discriminator will tell you that the images that you are creating are real and not fake. Therefore, when we are training the generator now, after we train the discriminator, now we are going to train the generator. He is making images, and then the images that he makes are fake. But I want to get it to discriminator. If the discriminator tells me that the image is fake, so the generator says no, it's not good. So it needs to update its weights. It needs to get better. Uh, we need to train him as a neural network, as a neural network, to make images such that the discriminator will say that they are real. So we have a discriminator that will train to differentiate between real and fake. We now go to the generator. We are making the images. We want to make them as real as possible, such that the trained discriminator, will be perplexed and describe the images of the generator as real. So the generator creates images, process them throughout the discriminator, and when the discriminator says that they are fake, the generator, it, it, it's like a loss function that is higher. We're expecting to get real. If the discriminator gives us fake, So the loss function would be higher because we want label of, let's say that real, but we got fake. So the generators updates like every other neural network with loss function, with gradient descent, with backpropagation, all in order to get the weights in the neural network of the generator better, such that it would create images. For example, it can be any other data that we want to make as real as possible, for example, images. So we're updating the weights of the generator such that it will make new, better images that will overcome the ability of the discriminator to know if it's fake or real. So updating, and then when we are finally over, we can make the discriminator even better with new real images, and this is, as the name suggests, adversary between the discriminator and the generator, which is better if the generator can fool the discriminator to think that its images are fake. So the generator becomes better and better because we are training it better and better to make images that will overcome the discriminator ability to differentiate between real and fake. And this is how we are creating a generator that make images as real as possible as our dataset. And the input to the generator is random values, usually from normal distribution. This is the input. From this input, the generator creates data, for example, images, and put it in the discriminator, processing discriminator, and want to get real or fake. Of course, the generator wants that the discriminator will tell that its data that was created by the generator is real and not fake. And that's the idea. Again, the idea is train a discriminator, a neural network that will learn our data from the world to identify our data. For example, images. Train it like a neural network with backpropagation, with loss function, and everything. The discriminator needs to know that are real images. He wants to discriminate between real and fake. So we also take fake images from the generator, for example, and give it a bunch of real and fake, for example, images, and tell the discriminator those are real, those are fake. Train it. Train yourself. If you are telling real is fake, it's not good. If you are telling fake is real, not good. You will have loss function that is high. Do propagation and train yourself until you are saying on the real images that they are real, on the fake images that they are fake, which came from the generator. When you are trained well, good job. Now we're going to the generator. The generator makes images. If the discriminator says that they are fake, the generator gets angry and says, not good, I need to train. And you are doing backpropagation, you're using loss, and you say the generator wants it to be real, but the discriminator said it's fake, so the loss function is high. Use gradient descent, backpropagation to update the weights of the neural network of the generator and make it better, make it better, make it better until the images with the new updated weights in the neural network generator gets very close to real and overcome the ability of discriminator to discriminate between real and fake. That is how we are training the generator to make a very, very similar data such as our input real world data, such as the discriminator cannot discriminate anymore between real and fake. And when it happens, if I give the discriminator now, I want to train again the discriminator, because what we are doing, we're training the discriminator, then training the generator to overcome the discriminator. After we are doing that, we are getting very more similar fake images to the real images. Then what we are doing, we are going back to the discriminator. Now we are saying those are fake images, those are real images. The updated image that the generators did, now you know that they are fake, train on this and know how to discriminate between real and fake. Train on this, so the discriminator becomes better. Then we're going back to the generator. Now he needs to learn. He makes fake images, and now the discriminator tells if it's real or fake. And the generator updates itself until the discriminator cannot differentiate between fake and real. Then we need to again train the discriminator on the new images of the generator. Tell him that those are fake, those are real, train again, and make yourself better at differentiating. Now, when the discriminator is updated again, now go to the generator and again make images. If the discriminator make say what you did was fake, train yourself, bake propagation up to two weights such that the new data like images will be better and overcome discriminator, and moving against the discriminator make it better. Going back to the generator make it better. Then going back to the discriminator make it better until comes a time where the discriminator cannot anymore discriminate between the images, and it's 50-50% for each image to be classified as real or fake from the real and from the fake generated images or data from the generator. Then we know that we did what we can. This is why it is called adversary networks, because the generator and the discriminator are in adversary situation. They want to win. They want to overcome each other. Discriminator wants to know to differentiate between real and fake better. The generator wants that will come the discriminator, and the discriminator won't know that what he creates is fake. In the end, when the generator is best as we can use the generator, seed him data such that we will create very similar data to the training, to the input data. And if these are images, so we create a very similar images as the real world data that we train on our system. So this is the idea of generative adversarial networks. And if you want to look at it when it's written here, generator, discriminator, generator needs to fake data, discriminator needs to differentiate between real and fake. Start with training, train the discriminator, training on the fake, training on real, tell him which is real, which of them of the data is fake, train it on it, tell him how to discriminate. Then train the generator. Create data from the generator, seed him throughout the data throughout the discriminator after we created it from the generator. If the discriminator did a good job and said it's fake, so the generator needs to learn and make it better. How you do it? You says, I want generator that the images you do will be classified as one. This is the outcome we want. And if it's classified as zero, fake, for example, so we need to get better and the loss function will be higher. And again, backpropagation, gradient descent and everything to update the weights using backpropagation. And repeat. Train the discriminator, then train the generator, then train the discriminator on the better images created by generator, then train the generator, then again train the discriminator on the even more better images and real data the generator and the real world data gives. And each time you train the discriminator again and again on the better fake and real world data, so that you will discriminate it, and then train the generator. So it's kind of loop that gets better and better. Okay, so this is it. This is a schematic representation of the data, real data assigned label 1, fake data assigned label 0, combine the fake and real, train the discriminator, update the weights. Then, after we train the discriminator to differentiate between true data and fake data, go to the generator and seed what he creates the discriminator, calculate the loss if the discriminator predicts it fake, so it's creating a increasing your loss, and again train the generator, update its weights and everything until it overcomes the discriminator. Then go back, train the discriminator again on the new fake updated fake data that is better, teach him how to discriminate, then go to generator, then go to discriminator, then go to generator, and you see how they're competing each other. That is the idea of generative adversarial networks, abbreviation of GAN. Thank you very much. If there are any correction or mistake, I'm sorry and correct me. And that is it. That about GAN, generative adversarial networks.